the airplane is used to control mosquitoes in many parts of the world. In the Tennessee River Valley, the Tennessee Valley Authority has used airplane larviciding in its malaria control program since 1935. The Muscle Shoals Airport near Wilson Dam, Alabama, is headquarters for TVA's airplane mosquito control operations. Here, all three methods of aircraft distribution of insecticides, dusting, spraying, and thermal aerosoling have been used. Prior to 1946 and the introduction of DDT as a mosquito larvicide, TVA used Paris green dust. Loaded into a hopper built into one cockpit of the plane, the dust was released through a discharge gate into a venturi, which increased the wind velocity generated by the plane in flight and effectively distributed the dust. Today, DDT and plant herbicides such as 2,4-D are dispersed as sprays in selected operational and research phases of the program. Essentially, this airplane spray equipment consists of a tank, a pump, and discharge nozzles. Several spray nozzles are often used to form a spray boom. Copper lines carry the solution from the tank to the pump and deliver the liquid under pressure to the spray nozzles. The nozzles release the solution as a spray, which is broken up and distributed by the air currents of the plane. Another method of treatment, thermal aerosoling, has been used in routine TVA larviciding operations since 1946. Assembly of the unit is not difficult. The exhaust stack of the plane is extended and rigidly secured to prevent vibration. A venturi is fitted on the end of the stack and bolted in place. A nozzle inserted in the top of the venturi throat breaks the liquid into a spray as it enters the exhaust stream. A second spray nozzle is seated in the bottom of the venturi throat. Copper tubing carries the solution to the spray nozzles. In this venturi, hot exhaust gases moving at high velocity break up the insecticidal spray into small particles of aerosol dimensions. Basically, the aerosoling equipment consists of an exhaust stack extension ending in a venturi, a tank to hold the insecticidal solution, and a pump to force the solution through copper lines to spray nozzles in the throat of the venturi. The two flat spray nozzles discharge the insecticide into the venturi throat as a fine spray, where the pressure and heat of exhaust gases break the spray droplets into smaller particles and create a smoke by vaporizing part of the solvent. The plane must not be airborne until structural alterations are inspected and approved by the Civil Aeronautics Administration. Developed during the war, thermal aerosoling units were first used to help control malaria in war areas. Airplanes still operating in distant parts of the world were equipped with thermal aerosol generators at this airport. Many types of planes are used for mosquito control work. For safety and efficiency, the planes must be very maneuverable with sufficient power to pull up sharply, easy to handle, have good visibility and downdraft, and not be too large to get into the breeding area. All CAA requirements met, the inspector issues a certificate of airworthiness. The plane is now ready to fly, but the aerosoling unit is checked and calibrated before insecticidal operations are undertaken. A graduated cylinder is placed under the venturi opening. The pump started, the control valve opened, and insecticidal solution flows into the cylinder. As it reaches the lower of 2 marks, a stopwatch is started. And stopped as the upper mark is reached. From such measurements, pressure and valve openings required to release the desired amount of solution are determined. The size of the DDT particles and the width of the swath released by the plane are important also in developing operational procedures. Uniformly spaced checkpoints are set up and a clean glass slide is placed at each location. A balloon marks the altitude the plane is to fly. The test is made with the plane flying across the center of the line of checkpoints at a predetermined speed. The air current set up by the propeller and the downdraft from the plane force the aerosol downward in a whirling motion. A slide waved in the dense cloud released by the plane collects droplets of insecticide and provides a check on the size of insecticidal particles discharged. The slides are collected in a slide box marked to indicate their position in relation to the swath. Examination of the slides gives an accurate measurement of the effective width of the swath. Normally, these preparations for aerosoling are completed before the mosquito breeding season begins, so that the pilot is ready to start operations as soon as field surveys reveal excessive mosquito production. Instructed to treat several large, scattered breeding areas, the pilots first make ground inspection trips to familiarize themselves with the general terrain and any obstacles to low flying. All flying hazards are carefully studied. A tower above the treetops. Power lines, a constant threat to low flying. All these are marked on his map. Topographical conditions are studied so that the pilot can orient himself readily in getting from area to area. The terrain will determine the direction in which he will make his swath, since a level or low area must be utilized for safe pull-ups and turns. An inspection trip by air and a few dry runs in each area complete preparations for larviciding. The plane ready, the pilot briefed, the actual operation starts as soon as weather conditions permit. Aerosoling is undertaken in the early morning or evening hours when wind and thermal conditions are usually most favorable. Landing strips and adequate facilities for loading insecticides are provided at strategic locations for economy and efficiency of operation. Loading by this method is efficient. Loading completed in the plane is ready to treat another area. Large, heavily vegetated areas are completely covered by overlapping swaths of insecticide. These provide the pilot with visible markers and enable him to judge lines of flight for good coverage with a minimum of overdosage. Important because excessive amounts of DDT may injure fish and other wildlife. One large area completed, the plane moves on. This ditch could be treated with ground equipment, but with the airplane already working in the area, the job is completed at greatly reduced cost. Many scattered areas are treated in a single day's operations. The application of DDT by airplane has reduced TVA's unit cost for larviciding operations by more than 50%, with a material increase in effectiveness. Effectiveness routinely measured by larva counts in treated areas, and by the collection of adult mosquitoes found resting in nearby barns and similar outbuildings. Used for large-scale mosquito control operations in this country by the Army, the Navy, the Public Health Service, the TVA, and others, aircraft dispersal of insecticides is proving equally successful in many other countries. Intelligently used by personnel trained in this work, the airplane has demonstrated its usefulness for mosquito control in many parts of the world.